Hello and welcome to a new video about using FreeCAD to generate G-code for the CNC. In this episode I'm going to make things a little bit different. I'm going to show you how I modeled these three pieces that you see on the screen. Well, there are two of them because you can see that the top and the bottom pieces are identical. I will show you how I modeled them. I will show you how I create the G-code, how I think about going to the CNC and the order of the operations, and I will also show you how I did things. I will explain the issues that I encountered while milling these pieces and the adjustments that I made along the way. So let me show you first the base that I had to make the shapes of these pieces. They are going to be aluminum. I had these two sketches. Let's transform these two sketches into 3D objects and then generate the G-code, generate the toolpath, go on to the CNC and mill them, drill the holes. The tapping, I won't be doing it on the CNC, I will be doing it by hand, but I will drill the holes before, so it should be very easy. So I'm in a new file, I'm in the part design workbench. I will create a new body. I will call it small plate, and the first thing that I'm going to do is this small plate. It says it's 8 millimeters thick, but I will do it 10 millimeters just as the second one. That is the dimension that it has to be. So let's create a new sketch in the XY plane, and I will use this tool which is called create slot. I'm not sure why it is called slot, but it does exactly what I need to get. The second part is setting the diameter. I won't be setting any dimension for now. First of all, I like it to be aligned in the positive X and Y, so let's do that. Select the half circle on the left, select the vertical axis and press T for a tangent constraint. Then I will select this point and the X axis, press O for point on object, and now it will always be in this corner. Let's take a look here. I can see that it needs to be 15 millimeters wide, so let's set the distance between these 2 points, press I for a vertical distance constraint and 15 millimeters. Now let's draw the circles. I have 4 circles. This one will be exactly in this point. Let's select the circle tool, draw 1 circle here, 1 here, and I need 2 more. Of course the fourth will have the point, the center point along this arc. And now I will select these two, and the first one, press H for a horizontal constraint. And now let's set their dimension. I can see that all 4 holes are 5 millimeters in diameter, but I also know something. These two are going to be threaded with an M6 thread, so I will leave them as 5 millimeters. These are the two. Press E first to set them equal, and then KO to set the diameter for the first one. Type 5 millimeters, and now they are both 5 millimeters in diameter, and the other two need an M6 screw to pass through them, so I'm going to make them again. Press E to make them equal, and then KO to set the diameter. I'm going to set this to 6.2 millimeters. This way I'm sure the screw will easily pass without having too much play in the hole. Now let's set the distance between all these holes. I can see in the sketch that from this hole to this one I have 32 millimeters. Select their centers, press L for a horizontal distance, 32 millimeters, and between these two I have a distance of 45 millimeters. Again, select their centers, press L, 45. But there is still something missing here, which is the position of these 2 points, including the end of the entire piece. What I know from this drawing is that this hole here is equally distanced to these other 2 holes. So first select the centers of these circles, then the last one will be this center, and press the symmetric constraint. Now you can see the sketch is fully constrained. I can close it, and with the sketch selected, make a pad of 10 millimeters. As I've told you, I'm going to make this piece also 10 millimeters, just as the larger one. Press enter, and there is one more detail that we need to do, which is the chamfer on these 2 holes. I will do it using the chamfer tool in the part design workbench. Select the top circle for both holes, select the chamfer tool, and for a certain reason this one hasn't been selected. Let's click on the select button, select this hole too. Now click back on the button which turned to preview. I can see them easily here. I will change it from equal distance to 2 distances. The first one is the depth. You can see it modifying when I scroll, and the second one is the diameter. I'm going to use a 3 with 3 millimeters. I could have also used an equal distance. Setting 3 millimeters was the same thing, but I'm going to use the 2 distance because I like it this way. Most of the times these dimensions aren't equal, so I like to set them with 2 distance. I can now click OK. I have the chamfer, I have the piece ready. Let's create a new body and rename it large plate. select the first body and press space to hide it, move back to the large plate, create a new sketch on the XY plane. And now let's take a look at the second piece, which is a little bit more complicated, but it will also be very easy to make. So let's take a rough shape, let's draw a rough shape of this piece and then modify the lines accordingly to get a shape similar to this one. I don't have to have exactly this radius here for this line, I can make it just to look similar. If I had to make it identical, I would have imported the photo into FreeCAD and traced over that image. You can find a video about doing that on my channel, but for this one I'm just going to draw it to visually look similar. So let's take the polyline tool, draw something similar to that image. Well, it's not exactly similar, but we are going to modify it right now. Select this line and here I have this button, which is convert geometry to B-spline. After converting it to B-spline, I need to add a point, another point. Let's do the same for the bottom line, convert it to B-spline and add another point. Now I can drag these points and I'm going to get a shape similar to what I have there, except these two corners. For that I'm going to use the create fillet tool, select the first line, select the second one, do the same for the bottom. Now right click, select the two arcs and press E to make them equal. After doing this, let's move this piece, let's move it again to the origin. This point is going to be the farthest on the left, so select it, press L and set a distance of 0. Let's do the same for this point, which will be the bottom, press I and 0. I need these two arcs to be equal, so the first thing that I'm going to do is set these two centers, press V to set them vertical. I still can modify them differently by modifying their height, so for that select this point and this over here, press H for a horizontal constraint, do the same at the bottom, and now I know for sure they are perfectly equal. Now let's draw the holes. We have 4 holes centered and these 2 holes in the corners. Let's select the circle tool, draw the 2 holes here and the 4 in the center. I'm going to select their centers and press the H key for a horizontal constraint. I will do the same for these two, press V for a vertical constraint. They need to be vertical, but I want them to be tangent to be aligned to these 2 lines. Well, for that I will first draw the lines, then right click, select the 2 lines and click on this button, which will turn the lines to construction geometry. Now I can select the circle, select this line, press T for a tangent, do the same with this line, and I will do the same thing for the bottom. Select the 2 lines, press the construction geometry. Well, I made a mistake, I selected the circle. By selecting the object again and clicking on this button, it will toggle it back to normal geometry. Now select the circle and this line, press T for a tangent. I could do the same for this, press T for a tangent, but this will issue an error a little bit later. Let me show you. I now select the 2 circles and press E to set them equal. Well, I cannot do that because it's a redundant constraint. Select this tangent, delete it. Now I can select the 2 circles and press E to set them equal. You can see now I have this constraint. Let's give them a radius. Select any of the circles, they are equal now. Press KO to set a diameter and let's take a look in the drawing. Well, this dimension is way off the page, so I cannot see it, but I know it's an M6 thread, so the diameter will be 5 millimeters. Now I have these 2 lines set. Let's set the diameters for all these circles. I have these 2 which are M8. They are going to be first equal. Select them and press E. Now let's give a dimension to this one, KO, and it's going to be 7 millimeters in diameter. And for this 2, I need an M6 screw to pass by, so they are going to be 6.2 millimeters. First let's set them equal, and now let's press KO to give this one a diameter 6.2 millimeters. Now I have all the diameters for the circles, but I can still move them around. I can move them up and down, I can move them left to right. Let's set the dimensions. Here I have for the second hole, I have a 13.86 selected center, and since I have aligned my drawing to the y-axis, I don't need to keep on selecting the end of the drawing and this to set a distance. I can simply press L and give that value, which was 13.86. Let's set the dimension for this one, press L, and it has a distance of 44.27 millimeters. And for the last one, press L again and set a distance of 63.86 millimeters. Now the drawing starts to look similar to what we have here. We still have to make some settings, so let's first set the distance between the center of this circle and this circle here. Select their centers, press I for a vertical distance constraint, and I have a 14.7 millimeters. Let's move it a little bit to the right, and I also can set the distance between this corner and the center of this circle. Again, press I, and it's 26.69 millimeters. Now let's move this a little bit up so it looks as it should. I still have 6 degrees of freedom, and for that let's take a look at the drawing and see what we can fix. First, there's the distance between these two holes, which is 29.39. Select their centers, press I, 29.39. Now I have only 5 degrees of freedom. I also have the distance from the center of this hole to the beginning of the drawing, which is 84.27. So press L, 84.27, and the total length of this shape, which is 89.27. So this point should be the last. Press L, 89.27 millimeters. But I still have 3 degrees of freedom. First of them is the position of these points which define the arc. I'm going to set a distance for them, let's say 30 millimeters, and I still have 2 degrees of freedom. We still can move this circle, which is one of the degrees of freedom. I don't have a setting for this circle, I just have it barely touching the chamfer of this hole. So since the chamfer is going to be 3 millimeters, let's set the distance between this one and this one. Press L. I'm going to use 3.5 millimeters, the radius of the first one, plus 3.1 millimeters, the radius of the second one, plus the 3 millimeters, which is the bevel, but I'm not going to use 3, I'm going to use 3.1. I need just a little bit of space here, otherwise I might get some errors when creating the bevel. Since they are going to be tangent, there might be problems, so I will set a little bit of distance. Well, I still have 1 degree of freedom. I can see that this point is able to move up and down, but I know that this series of holes is in the center of the object. So let's create a new point. I create it somewhere else so I can easily select it. First, set it to construction geometry, press on this button, and now let's place this point on this line. Press O for point on object, and now select the top corner, the bottom corner, and our newly created point. Set a symmetrical constraint, and I have a redundant constraint because I have a point onto object. So since they are symmetrical, I don't need to set the point onto object. It will always be between these two lines, which both are on the axis, so I don't need the tangent constraint. But I will select this point and one of the centers of the circles. Press H for a horizontal constraint. Now you can see the sketch is fully constrained. I can close it, pad it again 10 millimeters, and I still need to make chamfers for these two holes. Select them using the control button and go to the chamfer option. Let's use equal distance this time, which is 3 millimeters. You can see here, if they were touching, most probably there would have been some problems, so setting that distance a little bit farther to the left was a good thing. Now I can click OK to close it. I have finished the design stage. Now let's create a job to mill all these pieces. Let's also turn the visibility on for this small plate, and now let's select them both. Go to the CAM Workbench and click on the job button, which will make a new job, but I need 2 of the small plates, so I will modify this value here. I now have 2. Click on the OK button. The first thing that I'm going to do now, the objects that I have created are hidden. What I can see on the screen is these 3 models, the large plate and the 2 small plates. Let's go to the placement, to position, and change the Y value for the first one. Let's also change it for the second one. Let's move it higher. But I don't like this approach. I have a larger toolbit, it won't be able to pass through here. Well, I didn't set a toolbit, I have just the default toolbit, so let's double click on the job, go to the tools menu, and I'm going to use the 3.175 millimeters toolbit, end mill. Now delete the initial one. I'm not going to set speeds now because I'm going to talk about speeds a little bit later. I just have this toolbit so I can have its dimension and make a reference to position correctly these items. If I take a look at the job, you can see here it is the origin in the corner of this object. So For the small plate 001, which is the one on the bottom, I'm going to have to move it on the y direction with a -1 multiplied by its width together with a toolbit diameter. So its own width is .shape.boundbox y length. But I'm going to add to this toolbit 001 diameter. This is the diameter of the toolbit, but I have an error here, a unit mismatch. Let's solve this. Make sure you include the dot before shape. The dot there will make a reference to the object that is being moved. That's why it starts with a dot. So type multiply 1 millimeter, and now you can see I have a correct result here. So if I somehow modify the diameter of this toolbit, the positioning will move accordingly. Of course, if I add another toolbit and I want to use it in an operation, this won't work. But anyway, whenever modifying the toolbit, you need to take care for everything there is to modify. Now let's change the position for this one. Here the formula will be a little bit different. Let's go and change the position. Press E to enter an expression. And now let's take a look. I can see that I have to move with the width of the larger piece. So to make that reference, I'm going to write large plate dot shape dot boundbox. You have to take really good care for upper and lower case, otherwise it won't work. Y length, and I will have to add the toolbit diameter. So toolbit 001 dot diameter. Again, I have to modify the y length and multiply it with 1 millimeter. Don't ask me why it automatically converts it when multiplying, but it doesn't when adding. You have to know this. If for adding or subtracting it doesn't work, it issues a unit mismatch. You have to first multiply them using millimeters. And now I have everything placed correctly. The toolbit will be able to pass through here, but I'm going to add a little bit 1 millimeter offset. I did the formula and I will subtract another one here. Of course it has to be millimeter. The same for the larger plate. I will add another 1 millimeter just to make sure the toolbit when cutting this side won't be deflected and mill into this side. Now everything is placed correctly except the origin. So for that, double click on the job. If I click on the refresh button, everything seems to work okay. Let's change the origin also. You can see that everything looks great, but it won't be that great after I click on the close button. You can see they are shifted backwards. So as you can see, it didn't work. That is because I have moved the first plate in the negative space. I want it to always be in the positive space, so click clear. Now I can write 0 here, and let's move the large plate farther up. Let's edit the expression. I'm going to move it with the small plate 001 dot shape dot boundbox dot y length, and I'm going to add the toolbit diameter plus 1 millimeter. And again, I have to multiply this by 1 millimeter, otherwise it won't work. Now let's add the parentheses so it's easier to understand what I have done here. Click on the OK button, and now the large plate is correctly placed. I still have to modify the small plate. I have the old formula here, and I'm going to add this value to that formula, plus and paste that other formula. Of course I can optimize this. I have a lot of plus 1 millimeters around here, but I'm not going to waste time with that. Just move it. Now after recomputing, everything is placed correctly, as you can see. And now let's double check we have the stock correctly shaped, we have the origin correctly positioned. Let's start creating the jobs. The first thing that I'm going to do, because I have a 12mm thick piece of aluminum, I'm going to make a facing operation to bring the stock to the correct dimension to 10mm. I select all the top faces and click on this button, which is MillFace. If I click on the apply button, you can see nothing happens, because even though I have selected these faces, they simply cannot be added to the base geometry. Instead, I have to select the faces one by one and everything works okay. Now if I click on the apply button, you can see the same problem with the pocket operation. The pattern is the worst there is. I will change from zigzag to zigzag offset and set an angle of 0 degrees. I will set this value because most of the cutting will be done on the X direction, and the machine that I have moves much smoother on this direction. You can use any direction you want. Set a top view now, and I can see that here I have a barely touching toolbit to the edge, so let's give a material allowance of 1mm. This will enlarge the area, but I still have a problem because it will make only one pass. Let's go to the depth tab and change the step down from the whole diameter of the toolbit, I will use a step down of 1 millimeter. Now if I click on the apply button, you can see that nothing happens, because if I go to the operation tab, I can see here I have a boundary shape bound box. I will change it to stock, check the use outline button, and I will close the operation. I still have to change something because I still have just one layer. I want to have more layers because the material is 2 millimeters thicker than I want. Go to the job and let's change the extension on the Z so the stock in the operation will match the real stock that I have. Now click on the OK button. You can see now I have the correct number of layers, 2 layers, 1 millimeter per layer. So I have finished this part of the job. I'm going to mill all these areas. This is probably useless, but I prefer to do it this way because I can make sure all the edges are correctly cleared. So here we are in front of my CNC. I have this big plate of aluminum. I have set the coordinates, the X and the Y, also the Z, using this probe. I think that's the correct name for it. I haven't milled aluminum in a long time. I hope I managed to set the correct feed rates and spindle speed. We will see about that. I also have prepared this can of WD-40. I'm going to make these plates in 3 stages. The first stage is going to mill this piece of aluminum, which is 12 millimeters thick. I'm going to mill it to 10 millimeters to flatten it, and then I'm going to make the holes, and in the end I'm going to make the profiling. Why am I choosing this order? Well, I want to mill the holes because I want to be able to keep the pieces down to the table using screws. This way I won't need any tags, and this will be much faster at the finishing stage. This is the toolbit. It's a 2-flute 3.175 millimeters. It's a 1/4 of an inch, I believe. Let's get started. So apparently the first try was a mistake. The toolbit broke after just a couple of centimeters, of millimeters actually. I think that also the toolbit was broken, was a damaged toolbit, a dull toolbit, because I can see here there are a lot of raised edges. It actually melted the aluminum instead of simply cutting it. So let's try again with the same settings. Well, I have to admit I didn't expect it to work so well. Now I will try to find a way to clean this mess up. The toolbit is cold, it didn't heat up at all. Probably the aluminum plate is just barely at the room temperature, so having a toolbit that cuts as it should is essential. You have seen what happened to the first toolbit, the one that didn't cut well. It heated up, it melted the aluminum and broke after just a couple of millimeters. You can see some lines here. They are mostly just visible lines. I can still feel them a little bit when running my hand over the piece. I could use the same job to make the other operations, but I prefer to copy this job. So let's press on the job button, and for the model, instead of solids and other things, I'm just going to leave the previous job selected. Click on the OK button, click OK again, and now I have another job which has exactly the same setup as the previous job. When creating jobs for just a single object, you don't really care about that, but just as in my situation, when I have different setup, I have multiple items, they are positioned different, the stock is different. Using the previous job as a template for positioning them is a very good thing. Change the visibility for the second stock. You can see that it positioned the items correctly, but the extension of the stock on the Z is 0, so let's change it to 2 also. Click on the OK button. For the toolbits, again, it didn't copy the toolbits from the previous operation. I just have the default tool, so double click on the job, go to the tools tab, first click on add and add the 3.175 millimeters, remove the default tool and Now I can make the operations to mill all these holes. This isn't going to be too difficult, or at least I hope so. You will see that I had a little bit of a problem which I had to find a workaround. But first, let's select the job, the newly created job. I will close the previous one to be easier to see. So select the job and create a new helix operation. For the base geometry, I will leave all these holes. Everything should be okay because all the holes are through the entire piece of material. If they had different heights, I would have had to split the helix into separate operations. Go to the depth tab and first change the step down to 1 millimeter. The full diameter of the toolbit is way too much for my machine, and I will also change the start depth. Instead of 12 millimeters, I will select, let's say, this line and press on this button. Now I have a start depth of 10 millimeters. I changed the stock to 12 millimeters, but if I think about it, this stock is now 10 millimeters thick, so I shouldn't have done that. Well, I will set the start depth manually for these operations. It's not a really big problem. Now let's go to the operations tab and change the start from outside to inside, but this will result in a problem because the diameter of the holes most probably will be a little bit smaller because of the deflection of the toolbit. So I will take a chance and leave it to start from outside. For these holes I will have a very small piece of material in the center. Hopefully this won't damage the toolbit, but I will leave it like this. The step over doesn't really matter in this situation because I have these holes which are being done in just one single pass. For this one, since they are larger than the double of the diameter of the toolbit, no matter what step over I set, there will be 2 passes. That's all I need to add here. If I knew exactly what my machine is capable and what errors it mills with what error, maybe I could have set a small extra offset, let's say of minus 0.1 millimeters, and this will enlarge the holes a little bit. If the toolbit would deflect and I knew about how much, I could use this value, but I'm going to leave it to 0 because all the holes that I've previously milled in aluminum with this type of toolbit were the correct size, so I don't need to use this, but you can use it. As I've told you in the video about using the Helix, the making holes video, setting a negative value will actually increase the hole, setting a positive value will make the hole a little bit smaller. Now I can click OK. What I need to do is make the chamfer on these holes. I could switch the toolbit, take a V-cutter and mill all these holes, but I'm not going to do that. That is because I don't have an automatic tool changer. It would take a lot of time to reset the Z to change the toolbit by hand, so I prefer to use another option. I will create a 3D surface operation for all these holes. So let's select their faces, and this is going to be useless, but I have to do this to explain to you what goes wrong. I have all these faces selected. Go here, select a 3D surface operation, double click on it, and if I go to the base geometry, I don't have any base geometry selected, not sure why. I will have to do this again. You have to know that when clicking on things in the CAM Workbench, sometimes they open up correctly, sometimes they don't. Don't give up, try again, maybe leave the menu and they will show up. You can see that I don't even have the add button selected, so I will have to click cancel again. I will unselect everything, just select the job and create a new 3D surface operation. Now go to base geometry, select the faces one by one, and as you can see I can add them. Let's select 2 of them. So here is the problem: you cannot add more than 1 face at a time. I'm sure this will be solved. This is really unworkable in certain situations. If you have, let's say, 40 faces, having to select them one by one and go to the add button is almost impossible, so I bet this will be solved pretty soon. Now let's go to the depth tab again, set the start depth to the correct start depth to 10 millimeters, set a step down of 1 millimeter, click on the OK button. Now let's go to the most important tab, the operations tab. For the bounding box, I'm going to leave it as base bound box. The layer mode, the scan type is going to be planar, the layer mode single pass, but I'm going to change the cut pattern from line to spiral. This is the most important setting because this way it will move in circles and the resulting surface will be exactly as I want. Now let's test it. Let's click on the apply button and you will see what I was talking about, why this approach selecting all these faces doesn't work. Well, you can see that instead of spiral in each of the faces, it created a huge spiral, I believe. So I will have to create a 3D surface operation for each of these. It's not really a big problem, just remove everything, click on the apply with one face. I still have to make some settings because you can see that this spiral is just one movement, for sure won't create such a shape. Go to the operation and I will change the step over from 100% to 5%. Now click on the apply button. It will take a couple of seconds, but I now have the operation just as I want it. I still have some up and down movements here. For that I will check the optimize step over transitions, and now I just have one spiral toolpath. Everything works okay. So now click on the OK to close this 3D surface operation, and I will have to select it in the tree. Click on the copy operation button, double click on the operation, go to base geometry, remove the initial face, select the next one, click on the add button, click on OK, and I will repeat it for all these holes. What you might take into account when duplicating all these surface operations, whenever you have multiple operations, try to select the faces in a certain order, because even though it looks like the cutter head will start from the origin, it will remain at the last position, and selecting them in one order will reduce the air time. So it's a good practice to select them in the order that you want them to be milled. And now that I have everything ready for milling the holes, for making these chamfers, I know you might say that it's a waste of time, but after setting the speeds for the toolbit, after taking into account the machine, the material, the toolbit, and setting their speeds, I will show you how much these surface operations take. But I can tell you from now that it will take a maximum of 2 minutes to gather all these 6 holes. So stopping the job, changing the toolbit, resetting the Z value, then changing back again the toolbit to get an end mill to cut the outlines would mean much more time. And since the lines are so close together, you simply cannot or barely see the difference between a 90-degree V-bit and this type of milling. So that's why I chose this solution. Sometimes it's faster, sometimes of course can take a lot longer. So in those situations I'm going to use a normal V-bit and a deburr operation. After cleaning everything as much as I could, I can now put some screws into these holes. I need 6 screws. I will put them into these holes. Now let's create a new job based on the previous one. Click on the job button, leave the job selected, make sure it is selected in the tree, click on the OK button. Let's go to the tools. I know that it doesn't copy the tool. Select the new tool bit, click on remove. I will also leave it with 0. Click on the OK button, and let's hide all the previous operations. The model is already hidden, but the stock is not, and I also have to show the stock for the last job. If I hide it and show it again, I will also see the origin, just to make sure everything is okay. Even though for the previous operation I told you that I didn't need to change the stock value, for this one I need to do it, because here the MillFace operation has ended and the toolbit will also cut some 12mm thick material. So let's double click on the job and change the Z extension to 2. Click on the OK button, and this will be probably the easiest operation to set up. Just select the job, click on the profile button. Let's go to the depth and change the step down to 1mm. Click on the OK button, make sure the start depth is 12mm. This time go to operation. I will leave everything just as it is. Click on the apply button, click on OK, and I have set this operation also. So now everything is set up except one thing, the feed speeds. I cannot tell you the correct way to calculate the feed speeds. Of course, there are formulas based on the shape of the toolbit. For sure they are useful, but what is the most important part about setting the feed and the spindle speed is the way your machine is built, the rigidity of the machine, the hardness of the material. So there's not a universally valid formula, there's not a formula that you can use for any type of material. You can look at certain other operations, remember what worked, what didn't work. For me in this situation, I've taken a look at an older operation, and each time I mill again some material that I have already milled, I try to push things a little bit farther, push the speed a little bit higher, and this way I can make sure I won't damage too many tool bits, but I try to improve things to make things work faster. For this operation I'm going to open all the jobs, go to the tools, and I'm going to use a horizontal feed speed of 800 millimeters, a vertical speed of 500 millimeters, and the spindle speed of 12,500 millimeters. I could have used much higher speeds, for example 1,500 millimeters, but for such a small tool bit I would have had to use a much smaller step down and the total time would have been bigger. So these are the settings for this type of material. For aluminum, I believe it's a 5000 series aluminum, and of course my machine with this certain tool bit. You can take them as a guide, but you must know that there's no identical setup, so learning how to set everything up is a matter of experimentation, a matter of trial and error, and over time you will know exactly what setting to use when milling certain types of material with certain types of tool bits on a specific machine. So let's add some little more WD-40, and hopefully everything will work okay, the pieces will come out right. I can already see a problem, which is this piece. This most probably will fly away. Let's see what is under all this pile of aluminum. Let's see what turned out. Hopefully everything is okay. I will try to avoid messing up the CNC too much. I still have to cut the tags that were here for holding these small pieces. You can see the finish is almost perfect, and I'm not sure how you can see it on the camera, but moving my finger around it, I can feel it just as a perfectly flat surface. So this is all. You have seen how I designed the pieces, how I created the toolpath, how I split the operations. As I've told you, when milling them, I have first flattened the piece so I get the correct dimension of the stock. Then I milled the holes because I took advantage of the fact that the pieces have holes in them. This way I was able to hold these small pieces to the table very easily. I have also shown you how to solve certain situations that maybe you didn't realize when first creating the toolpath. As I've shown you, I had to create some tags to hold the remaining pieces to the table to avoid them flying around. I hope this was useful. I hope you will learn something from this video. I'm sorry for not being able to tell too much more about selecting the proper tool bit and the feed speeds and the spindle speed, of course, but as I've told you earlier, I think that is a thing that you will have to learn for yourself on your machine. Of course, you can take a look at some guides. You can also take a look at my videos to see what I usually tend to use, because my machine is a custom-made machine. It's not the weakest but also not the strongest. The tool bits are pretty normal tool bits. I tend to use 2 flutes tool bits for aluminum and 1 flute tool bit for wood and acrylic. Thank you for watching. Don't forget to subscribe. See you next time for the next video about using open source software to generate G-code for your machine.